Hello, I welcome you all in this presentation related with the subject fundamentals of surface engineering. And we have started the surface characterization of the modified surfaces to see how effectively the surface modification has been carried out so that we can take decision about the suitability of these modified surfaces for given application. So, we have already talked about the importance of the characterization of the modified surfaces, and you have seen that it is good to characterize the modified surfaces in terms of the chemical composition, in terms of the mechanical properties, metallurgical properties, tribological properties, and then we have to see the integrity and soundness of the modified surfaces apart from the dimensional properties like surface roughness and thickness. So, we will be starting our the different techniques which are used for these characterizations of the modified surfaces. So, we will be starting with the dimensional properties of the modified surfaces, and under this like the surface roughness will be taking up first. We know why it is important to check the surface roughness, so that we can take decision about whether the as modified surfaces can directly be used in a given application, or they need secondary processing for improving the for reducing the surface roughness and improving the surface finish. We know the surface roughness indicates the kind of ups and downs, peaks and valleys present at the surface. So, such kind of the ups and downs or the peaks and valleys present at the surface, they indicate the kind of irregularities present at the surface, and to quantify this, one of these most commonly used parameter is called RA, which is center line average value of these peaks and valleys. So, it indicates the height average of the height and depth of these peaks and valleys present over a certain length. That length is called sampling length. So, this length is normally small, and in this one we measure what is the height and what is the depth of these valleys which are present. So, basically the extent of ups and downs present at the surface, modified surface, is quantified, and this can vary significantly from say like 1 micrometer or even less than 1 micrometer to the like 100 micrometer, depending upon the surface modification process being used. There are two broad categories of the methods which are used for characterization of the surface roughness, and so surface roughness. There are two broad categories. One is those methods where the contact between the measuring instrument and the surface of the workpiece takes place, that is called contact type surface roughness measurement. And in this category, basically we use one stylus based method, where stylus is moved over the surface of the component which is to be quantified with regard to the surface roughness. And then there is another category, non-contact type method. So, in this case basically the light and the laser based methods, these are called laser or optical methods, are based on the non-contact type of the surface roughness measurements. In this case, just like this category reflects, there is no contact between the measuring instrument and the surface of the component whose roughness is to be measured. So, we will see what are these methods and how do these methods work. So, stylus based method. In this case, one very pointed stylus of very small diameter is used, and this stylus is moved over the surface of the component whose roughness is to be measured. So, this is a stylus. In very controlled way it is moved over the surface of the component. So, using automated control, the stylus is moved over the surface whose roughness is to be modified. So, this is the substrate, and like say this is the modified zone. So, the surface of the modified zone is to be surface roughness of the modified zone is to be measured. So, a stylus will be moved over the surface. So, as soon as it the stylus scans the surface of the component, it according to its the height of the peaks and valleys, stylus will also be moving up and down when it will be traversing or scanning the surface of the component. So, this up and down movement while it is scanning the surface is used to quantify the roughness values. Since the extent of the movement is very limited, movement is very less. So, in order to make it measurable, this up and down movement is magnified or amplified using two approaches, or both the approaches are used in combination. One, it uses the lever principle for amplification, and then it also uses the electronic methods. So, the extent of up and down is increased using the suitable lever principle, so that whatever little bit up and down movement of stylus is taking place, that is magnified at another end as per the leverage, and which is further magnified using the suitable capacitors or electronic methods, so that we can get the extent of up and down movement of the stylus to the measurable or the quantifiable level, so that the extent of the RA value over a particular length can be measured. Since in this case the stylus is moved very slowly over the surface, so that it can properly scan the ups and downs present at the surface, and therefore, so this is one aspect. The slow movement of the stylus and the length over which stylus is moved is also very limited. So, this one is called sampling length. Sampling length is small. So, if the surface roughness of the large area is to be scanned, then stylus will be used to scan the surface roughness over the number of places. So, the two things are there. One is the smaller sampling length, and second, the slow movement of the stylus. This makes the surface roughness measurement of the large surfaces difficult, and that is why so this we can consider as one limitation of the stylus based method, because it takes time for quantifying the surface roughness of the large surface area of the component which is to be characterized. So, as I have said, this is used for measuring the micro level surface roughness measurement, and if the nano level surface roughness is to be measured, then there is another equipment which is called atomic force microscopy. This helps us to measure the surface roughness of very lower values like 20, 30 nanometers. So, but for the micro level surface roughnesses, simple stylus-based surface roughness measuring instruments are sufficient. Atomic force microscopy is used for measuring the surface roughness of very small area of very high level of the surface finish. So, if we consider the limitations of the stylus method, the first one is it is time consuming, and it needs to be repeated at a number of places for the for scanning the large area, because the smaller sampling length is used in one go, and then it cannot be applied on the moving objects. So, not for moving objects, since it requires the contact between the stylus and the surface whose surface roughness is to be scanned or measured, then and for that object has to be in a stationary position. So, and that is why this method cannot be applied for measuring the surface roughness of the moving objects. So, these are the two limitations as far as the stylus based methods are concerned. There is another category which is of the non contact type of the surface roughness measurement. It uses the laser or optical methods. In this case, there is no need of contact between the surface and measuring equipment. So, this is one very good side. And how does it work? Like the surface which is to be scanned or whose roughness is to be measured is directed with the beam of the laser. So, based on the kind of ups and downs present at the surface, the laser will be reflected in the different directions, and this reflected beam is the pattern of reflection of the laser beam is analyzed to quantify the surface roughness value. So, in this case basically we are not moving any object which is coming in contact with the surface to measure the extent of ups and downs, but the laser or any suitable light is directed onto the surface of the component. So, based on the reflection pattern of the reflection, we try to quantify the surface roughness of the component. So, this basically is an indirect method of surface roughness measurement. So, it may not be accurate, and another issue is that no direct reading. It is indirect method of, because based on the reflection we try to relate it with the extent of surface roughness which is present at the surface, and then we try to come up with some value of the surface roughness. So, this is indirect method. It may not be very accurate, and it does not give the direct reading of the surface roughness. Then there, so basically this laser based method gives us the 2D plot of the kind of the ups and downs which are present at the surface. There is one equipment which is called confocal scanning microscope. This is also a laser based method, but this is a confocal scanning microscope. It is also instead of the two dimensional variation of the ups and downs present at the surface, this equipment gives us a three dimensional variation or three dimensional pattern of the ups and downs present at the surface. But the most commonly used method of measuring the surface roughness is the stylus based method. However, it comes with a limitation that it cannot be used for measuring the surface roughness of the moving object. While implementation of the stylus based method for measuring the surface roughness is little bit difficult as compared to that of the non contact based methods. Now, we will see how to measure the depth of the modified zone or there is the thickness of coatings. So, there are basically the different principles which are involved, like we have seen that the surface metallurgy, surface modification we can carry out using three methods. One where surface metallurgy is modified. So, just the near surface layers, either the structural modification will be carried out or it will be work hardened. So, in both the cases either structure is modified or it is work hardened in the work hardening based methods like burnishing and shot peening. So, to quantify the depth of the modified zone, in this case where the hardening transformation hardening is used like flame hardening, laser hardening or induction hardening. In these methods, basically the combination of the hardness and the microstructural variation is used to quantify the depth of the modified zone. So, it combines the two methods to really arrive at the depth which has been modified using the transformation hardening based methods like the flame hardening, induction hardening and the laser hardening. On the other hand, if the work hardening has been used, then we have to see the extent up to which the plastic deformation has been realized. So, the grain structure, this we can realize from the grain structure, up to what extent, up to what depth the elongation or the grain structure has been deformed. And the second parameter which is used to quantify the depth up to which modification has taken place using the work hardening based methods like burnishing or the contour rolling or shot peening. So, in that case we also need to measure the hardness variation, and if we see in both these cases, if we measure the hardness from the surface to the substrate, then hardness will be variation may be like this. So, this is showing the extent up to which the surface either microstructure has been modified in the laser hardening or the distance up to which the work hardening has taken place. Thereafter, its magnitude will be decreasing. So, this is how we can quantify the depth up to which the surface modification has taken place in case of those methods where just a surface metallurgy is modified. Then we have the another category of methods like the surface composition is modified using like carburizing, nitriding or cyaniding, or likewise there are other methods where PVD or the CVD methods are used or ion implantation is used. So, in all these cases these methods are based on the chemical composition modification. So, the depth of the modified surface in this category of the methods, or if the surface has been modified using the second category of the methods, then there will be change in chemical composition of the surface layers. So, like say this is the depth which has been, this is the depth up to which the modification has been implemented using any of these methods like carburizing, nitriding, cyaniding, PVD, CVD or any other methods. Then for this purpose primarily we have to measure the chemical composition modification. So, we can perform the line scan from surface to the subsurface zone and see that the distance up to surface modification up to the required level has been realized. Apart from this also can be confirmed through the hardness measurement. If the chemical composition has been modified up to the required depth and it has delivered the expected change in terms of the improvement in surface properties like the hardness. It can also indirectly be measured with the help of the microstructural variation. So, these are the three parameters that we can measure to see, or combination of all these three will give us the better representative picture of the modified depth of the modified zone using the chemical composition based methods. And in case of the third category of the methods where a layer is deposited at the surface, we need to measure the thickness of the modified layer. So, to measure the thickness of the modified layer, like this is the substrate and this layer has been deposited either by the weld surfacing or thermal spraying or like electrolysis or electroless process. So, in all these cases thickness of the layer or the coating is to be measured. So, for measuring that there are three methods which are commonly used. These are like these methods for measuring the thickness includes like weight measurement, then second is the indentation and third is the ultrasonic method. So, why it is important to measure the thickness? It is very important to measure the thickness of the modified zone or thickness of the coating, because in case of the coatings wherever a layer is deposited, we need to see that the bonding between coating and substrate is good. Why? Because whenever a component is put in use where and the surfaces modified surfaces are interacting with the other components or other medium where the shear stresses are acting at the surface, like during the abrasion, during the adhesion, like one component modified surface is matting with the another component and there is a relative movement between them, then the modified zone means the layer which has been deposited will be under the, especially under like say adhesive wear conditions, the surface due to the friction force experiences the shear force, and because of the presence of this shear force the shear stresses will be acting in the modified zone, and because of this if the shear stresses magnitude is maximum at the interface level, then it interface means the coating substrate interface, then the chances for the removal or elimination of the coating from the substrate will be very high, and that is why like say for the given loading conditions, if the maximum shear stresses are acting within the coating, then it is fine, probably coating can sustain those shear stresses, but if the maximum shear stress level is acting occurring at the interface, then chances for the removal of the coating from the substrate becomes high, and therefore in light of the location where the maximum shear stresses are acting in the modified zone, we need to take a decision about the thickness of the modified zone. For example, if the maximum shear stress is occurring at 25 micrometer below the surface, then it will be appropriate to have the coating of 50 micrometer, so that the maximum will be occurring within the coating itself. If we deposit the coating of the 25 micrometer thickness only, then the maximum stresses will be acting only at the coating substrate interface, and that in turn will increase the chances for the delamination of the coating, especially during the surface, So, we should take a proper decision about the depth up to which, or the thickness which is to be achieved after the surface modification, so that the maximum shear stresses do not occur at the coating substrate interface. Now, quickly I will go through the different methods which are used for measuring the surface thickness of the modified surface. So, one is for thickness measurement we use the weight method. So, in this case the component which is to be whose surface is to be modified, its initial weight is taken first, and then after the modification again we take the weight of the component, and difference of these two will be indicating the weight or the kind of the amount of the material which has been deposited in form of coating. So, if we have the length of the coating and if we have width of the coating for a given material having the density and then change in weight. So, which dimension is left now is the average thickness. So, if we have the data about the weight gain due to the development of coating, if we have the information about the density, if we have measured the length and width of the coating, then average thickness of the coating deposited can easily be measured using this weight gain method. So, this is how we can calculate. This is again the indirect method of measuring the thickness, where weight gain method is applied, or weighing the sample or the substrate before and after the coating is applied for measuring the thickness of the coating. So, now here I will summarize this presentation. In this presentation basically I have talked about the two aspects. One was the surface roughness, and there are two methods for measuring the surface roughness. One is the contact type and another is the non-contact type. Contact type is one of the most commonly used method for measuring the surface roughness, as it gives the direct reading of the surface roughness value, while non-contact type methods are good for measuring the surface roughness of the moving objects. However, this method may not be very accurate. And then we have also talked about the different methods of measuring the thickness of the modified zones, and there are two more methods of measuring the thickness of the coatings. About that we will be talking in the next presentation. Thank you for your attention.